In the previous tutorial, we looked at how to use readers and writers, specifically to change between data formats and coordinate systems. In this tutorial, we will learn how to use transformers. As the name implies, these elements transform our data. To show some useful transformers and how they are added to our workspace, we will solve a practical problem. Our task is to take the data we have received through a shapefile and an Excel file, manage the attributes, do a calculation, merge different datasets, filter our data based on a condition, and then write out our end product to an AutoCAD DWG file. In order to accomplish this, we will use several common and very useful transformers in FME. This flowchart shows our task. So we will combine a shape and an Excel file to get an end product, which is a AutoCAD file with project areas that can house 650 people or more. So we start by opening a workspace in FME. The first thing we will need to do is to import our data. One neat possibility is just to drag and drop your data, like this. You go to the folder where you have your data, and you can just, this is the Excel file, number of houses. I can just drag and drop, and it recognizes the format. I press OK. We do the same with our shapefile, which contains the spatial aspect of our project areas. It recognizes the format automatically. And now we have our imports. And if you hold down the control key and press so that both are highlighted, you can press the bookmark to organize your workflow just as you like. I will just call these together as imports, like this. So here I have added the Excel file that contains project areas. So if I run this and look at the data, you see it has the project area name and the number of houses that can be built in each of the project areas. The other import is the shapefile. And if I run this and examine the data, you can see the spatial placement of the project areas, and we have the name for each of the polygon feature here. We will start off by calculating the number of people that can be housed within the different project areas. We here assume there will be 2.5 people per house. So for this specific part of our workflow, we used a transformer called Expression Evaluator. So all we need to do is to start typing Expression Evaluator, and when it's here, you can read something about the transformer, which gives you an explanation of what it can do and so on. So I'll just double click it, and it becomes accessible in my workspace. So because it is the Excel file that contains the number of houses, I will connect this data source to this transformer. And note that we always work from left to right, meaning our imports are at the left, the transformations, they are in the middle, and our final end product, that will be on the right hand side of our canvas. So now that this is connected, we can click on the cogwheel here. And here we can specify the name of the attribute that will contain the values that we want to calculate. So in the result field here, I type num of people. To calculate the number of people, we will use the number of houses and multiply it with 2.5. This is the number of people we assume will be living in each house. So in this area, we will create our expression, and because of the floating point number, I will start off the expression by using the ceiling math function. So we round up our values, our end value. So I go to math function here and double click the ceil, and it gives you an indication of what you need to put in. You need to put in the value here where it says float and the precision. So I know I want to have a whole number, so my precision will be 0 here. And for the value or the float that we will put in here, we will go to FME attributes, feature attributes. This is where we get access to our data's attributes. So I double click on number of houses and I type the multiply sign and type 2.5. And I can have some space there. So now we have for each feature the number of houses multiplied with 2.5, and the ceiling will round it up to the closest whole number. And then we press OK. And we can just run our expression up until this point, and we can see that we have in our data here, we have added a new attribute column, which is number of people. And we see that if we would do this manually, 2.5 times 243 would become 608. Even though this is a rather simple workflow that we will be building here, it is always good practice to comment the various parts of the data flow. So we can press once on the Expression Evaluator element, like this, and then we can click on the annotation tool, insert annotation here. By doing this, you will automatically get the possibility to write something about this part of the workflow. So I can write here an alternative is to double click on the transformer and give the transformer itself a more descriptive name. But I normally just use the annotation, but you could double click and change this name to something more descriptive. And we press OK, and we see that the name became rather long, but that is also a possibility. And just to note this, you see the magnifying glass here is yellow. That means that something has changed within this transformer, and the previous run was done before that change. So if we run up to this again, you will see that the magnifying glass becomes green again. So now we need to figure out how can we combine the data or information from this part of our workflow to the shapefile part of our workflow. To do this, we can use the feature merger transformer. So we start typing and double click on the feature merger here. Double click it. And because I had this one highlighted, it automatically attached itself to the transformer. But here we see two red triangles or imports for this transformer. We have the requester and supplier, and this means that we can add something to it, these red triangles. And the requester for the feature merger. So the requester is the one that will receive information from the data that is provided. So since the shapefile contains the spatial aspect, I will put this as our requester here. And the data I want to add to this shapefile is the Excel data here. So I will take this and put it as the supplier. Now we can press the cogwheel here and set the join on logic. So we see that we can put in something for the requester, the supplier, and the comparison mode. This is to allow the transformer to match the attributes for the different features so they can be merged together, the different data sources. For the requester, I can press the arrow here and go to the attribute value and set the name, because I know that in both of my data sources, the project name is accessible and is a unique identifier. And for the supplier, I do the same. Press the arrow, attribute value, and here it is called project name, which is probably a more suiting name. So I choose this one here. And for the comparison mode, I just choose automatic. You have the possibility to choose if you want to do the comparison, if it's a string value or if it's a numeric value. But I just keep it on automatic. And when I press OK and run up until this point, we see that when we look at the merged data here, we can see that we have the spatial information where the project areas are in the map, and we also have the information from the Excel file, the number of people that lives and the number of houses. Everything from the Excel file is given to the requester, that is the shapefile here. But we see that the name, project name for the shapefile and the project name attribute for the Excel file are both in the same data now. So we have to do some attribute management in order to fix this. And the transformer that is used to do this is conveniently called attribute manager. So I double click on this, and this transformer again lets us manage our attributes. So you can, if we look at the actions, you can set a value, you can do nothing, you can rename the attributes, the attribute columns, you can remove attribute columns, or you could set a default value. I want to remove one of them, and I will remove the attribute column that is just called name, because project name is much more descriptive for this. So I highlight the name attribute here, and for the action I set it to remove, and this is pretty much it. I press OK, run up until this point. I look at my data, and if you look at the table view here, we only have the project name, so our task is completed for this purpose. I will make some space here. But while we're at it, we could just do a rename of the attribute column that is called number of people. We could have changed that in the expression evaluator, but just let's say that our data was like this, just to show you how it can be done. Then I would go to the number of people, I would do rename, and the output attribute I would call number of people, like this. So now we have the action rename, and we have set what the name should be, number of people, without the underscores. Okay, the magnifying glass becomes yellow. Something has changed since the previous run. Now it's green again, and we see that we have also changed the name of the attribute column. Could be handy. Now, our problem involved only keeping the project areas that can house more than 650 people. To do this, we can use one of the most used transformers in FME, the tester transformer. The tester transformer evaluates one or more tests on a feature, and the features are divided into two groups, the ones that passes the test and the ones that fails the test. So we will use that to filter out our data here. I type tester, double click the tester. I connect the data I want to do a test on. I press on the cogwheel, and here we have to provide it with some logic. So I set the attribute value here. In the left value, I want the number of people attribute to be bigger or equal to 650. And this is pretty much it. Now we have created one logic. We could expand and make more down these rows, but this is sufficient for now. So the number of people should be bigger or equal to 650. We press OK, run to this, and we see that 5 features from this string has gone into the tester. 2 passed, 3 did not pass. So if we inspect the ones that passed, we see that the number of people are 803 and 1420, which are these 2 polygons. So now we can add a writer and export the feature that passed this test into an AutoCAD DWG file. So we click the writer here and we type DWG and choose the AutoCAD type. I press the 3 dots because I want to specify the location and the name. So I will just call it project. So it's project areas over 650 people. So I press lagre, which is save in Norwegian. And I will do automatic for the layer definition, because when I press OK, I can give the layer for the AutoCAD DWG file a name, give it a descriptive name, which will be nice when you import your data into AutoCAD, or any CAD system for that matter. So now we press OK. We have our writer here. And I take the past data and put it in the writer and run to this for the writer. We see that the translation was successful. And if we check our folder, we see that we have a new file in our folder that is called project areas over 650 people, DWG file. So we have now accomplished our task by using various transformers in FME to do this. The goal of this video was to showcase the usage of common transformers in FME so that you can see how they can be used in a practical case. In future videos, I will be going through various problems I have encountered in my work and how I have solved them in FME. The purpose of this is to hopefully give you some ideas to how you can solve the problems you encounter. I believe it is very useful to see real-life problems being solved, because for your specific problem, you might need one part of the workflow I have created for a completely different problem. So stay tuned for these videos, and if you like this one, I would really appreciate it if you gave the video a like and subscribe to the channel. Have a great day, and I'll see you soon.